Dependence of EMF on concentration. Now, if you don't like the word EMF, just think of E cell. And if you don't like E cell, think of what's read on the voltmeter. So you can have a complicated chemical process going on, but the process that's going on needs to have something to do with electrochemistry, otherwise this isn't going to work. But if you measure what's on this voltmeter and it's hooked up to some type of sensing medium, you can actually calculate the concentration of what's reacting on the surface of that electrode. So with the right engineering, you can develop sensors and electrochemical sensors that'll give you the concentration of enzymes of these electrodes in someone's brain, right? There's oxygen sensors in the environment and in your blood, DNA sensors. So the idea here is that by measuring that voltage, you can calculate the concentration at that time that you're reading the voltage of whatever's going on in the process. Again, it could be something as weird as inside your brain. It's crazy. Okay, let's get started. Dependence of EMF cell voltage on concentration. When a electrochemical cell is at equilibrium and under standard conditions, below equation is used to get the potential of the cell. Okay, we've had that before. That E0 cell is 0.0592 over N log of K. Nothing really new there. What they're saying here, this is what's new. When an electrochemical cell is not at equilibrium or not under standard conditions, the below equation is used to get the potential of the cell. Okay. Now, if it's at equilibrium, it's dead. What I mean is, think of this battery. If it's at equilibrium, what's the reading on a battery that's dead? I mean, let's hook it up and find out. Let's see, minus to... It's 0. So if the battery's dead, it's at equilibrium, there's no cell voltage. Okay? So that's why E0 cell is 0 when you're at equilibrium. And that's why the expression is easier to use. But when you're not at equilibrium, it's not going to be 0 anymore. When you're not at equilibrium, this battery's not dead yet. So when you're not at equilibrium, this is what it's going to read on the voltmeter, E cell. Okay? So how do you find the variables in this equation? Well, E0 cell, just like before, we use the tables, right? N, that was the number of moles of electrons that cancel, right, in the overall reaction. Q, remember what Q is called? The reaction quotient. Do you remember when we replaced K with Q? When you were at non-equilibrium concentration conditions. So Q is just, an equilibrium constant expression. It's just that you're not at equilibrium, so they call it a Q instead of a K. Okay, so it's kind of an ugly equation. So let's do some calculator practice. I'm going to do all this in one step because I just prefer it that way. So what I'm going to do is I'm going to start here and then do the bottom, find what's inside this log first, and then just go one step at a time. So with the calculator all ready to go, 0.01 cubed, shift x cubed, hit equals, divided by 0.25 squared, hit x squared, equals, push log, times 0.0592, make it negative, divide by 6, hit equals, plus 0.35, 0.397, without writing anything down. Find the concentration of chloride. Okay, so what we need to do is we need to get this to look like some number equals the log of 0.02 over chloride squared. Right? Get it to look like this, then we'll raise both sides to the 10 power. Okay? So that's the game plan. First, let's bring this over. right? We'll have 0.25 minus 1.23, about negative 0.98. So negative 0.98 equals a negative 0.0592 all over 2 log of 0.02 all over chloride squared. So let's bring the 2 to the top, the negative 0.0592 to the bottom. .98 negative times 2 divide by 0.0592 negative is about 33.108. Now let's raise both sides of the 10 power. I get about 1.2826 times 10 to the 33 equals 0.02 over chloride squared. So you see what to do now? Bring the chloride squared to the top, right? Bring that 10 to the 33 to the bottom. I can solve for chloride. If you don't see it, let me write it out. Chloride squared would be 0.02 over 1.2826 times 10 to the 33. Okay, so find that, then take the square root. About 3.95 times 10 to the negative 18. It's concentration, so that would be big M. Okay, here's what a lot of the homework is going to be like here. Find the cell potential of the following cell. So remember, EMF is just finding E cell. And notice, look at these concentrations. They're not 1 molar. So we have to use this expression. We are not under standard conditions. Okay, we are not under standard conditions. So in fact, you can always use this. You can always use, okay, for these. Because if you're at equilibrium, you just make that 0. Right? But they didn't say we were at equilibrium, so we better not do that. Might screw things up. So let's try it. E cell has to be E0 cell minus 0.0592 all over N log Q. Let's see if we can find out what these are. Let's find our 2 half reactions here. All right, so then we add them up, we get our overall reaction, find our E0s. Okay, let's see if we can find our half reactions. We have lead solid going to lead plus 2. That's an oxidation half reaction. So lead solid has to be on the product side here, right? Because it's an oxidation half reaction. Lead solid going to lead plus 2. Here it is. Lead solid going to lead plus 2. Plus 2 electrons. My E0 for that, flip the sign, positive 0.13 volts. The other half reaction is gold 3 going to gold solid. Reduction half reaction. So let's find gold 3 on the reactant side. Gold 3 plus 3 electrons forms gold solid. Gold 3 plus 3 electrons forms gold solid. I didn't flip it, so write it down. Positive 1.5 volts. Okay. So if I want to write an overall reaction here, I'm going to have to multiply top one through by 3, the bottom one through by 2. Then I will get my 6 moles of electrons to cancel. So I'll end up with 3 moles of lead solid and 2 moles of gold 3 forms 3 moles of lead 2 and 2 moles of gold solid. And my E0 cell is a positive 0.13 and 1.5, 1.63 volts. Will be my E0 cell. So I'm ready to plug everything in now. Let's see how it's going to look. My E cell is going to be E0 cell, which is 1.63 volts, minus 0.0592 all over N. And how many electrons canceled? 6. Log of Q. Now Q is products over reactants. So let's write the Q expression first. Products over reactants. Right? Solids don't show up, so I'll have the log of lead, but that has to be cubed, divided by gold, that has to be squared. Okay? So if I plug and chug, I can get my E cell. I just need to know what these concentrations are. And they told us. Where did they tell us? Right here. There's the gold concentration. There's the lead concentration. Your shorthand cell notation always gives you that information. It's going to be 0.01 cubed. And that one will be 0.1 squared. So my E cell, so what will be my E cell? I'm going to do the log part first, 0.01 cubed divided by 0.1 squared, it equals a log of that times 0.0592, it's negative, divided by 6, it equals plus 1.63, 1.67 volts. It's my E cell. Find the EMF of this cell. Okay, so again, use this expression. Determine what the two half reactions are and get your N and your Q expression by adding up those two half reactions. Try it. So chromium solid has to go to chromium plus 3. Copper plus 2 has to go to copper solid. So you can finish the balancing. You need 3 electrons there. You need 2 electrons over here. Let's see if we can get what those E0s are. Chromium solid going to chromium 3 is an oxidation half reaction. So I need to find chromium on the product side. Here it is. Here's chromium on the product side going to chromium 3. So flip the sign, positive 0.74 volts. Copper plus 2 going to copper solid, that's a reduction, so copper plus 2 on the reactant side. Now here's copper plus 2 going to copper plus, not that one. I need it to go to copper solid. Here's copper plus 2 going to copper solid. Positive 0.34 volts. So I add up these half reactions. I'm going to have to multiply the top one through by 2, the bottom one through by 3. So my 6 electrons will end up canceling out. So I'll end up with 2 chromium solids and 3 moles of copper 2 produces 2 moles of chromium 3 and 3 moles of copper solid. My E0 cell will just be 0.74 plus 0.34 or 1.08 volts. So now I can write my expression. My E cell is going to be E0 cell, which is 1.08 volts, the values from the table, E cathode plus E anode, minus 0.0592 all over N, N was 6, log of Q, products over reactants. So chromium ion, and it has to be squared. Copper 2, and it has to be cubed. And what were those concentrations? See if you can find them. Chromium 3 is 0.01. Copper 2 is 0.25. So I'm going to find what's inside the log first. 0.01 squared divided by 0.25 cubed equals the log times 0.0592, it's negative, divided by 6 equals plus 1.08, about 1.10 volts. We my E cell. So that's what the voltmeter will read. The voltaic cell below has an EMF of 1 volt. So now they're telling us what E cell is. We know what the voltmeter reads. What is the concentration of the silver ion? Okay, do you see the game plan here? It's this expression. Silver ion is inside that Q expression. Silver ion is in here somewhere. So we need to set up the entire equation. And there's only going to be one thing missing, and that's the silver ion concentration. And that's what we'll solve for. So try to set it up. Find what the half reactions are, find E0 cell, find N, plug them into the Nernst equation, and then solve for the concentration of silver ion. See if you can do it. So tin solid has to go to tin plus 2, and silver ion has to go to silver solid. So we can finish these. I need 2 electrons here. I need 1 electron there. Let's see if we can look up the E0s. Tin solid going to tin plus 2. That's an oxidation reaction, so tin solid had better be on the product side. Tin solid going to tin plus 2. Flip the sign. Positive 0.14 volts. Silver ion being reduced to silver solid. Silver ion being reduced to silver solid, positive 0.8 volts. It looks like the top equation, I guess it's multiplied through by 1. The bottom one you have to multiply through by 2. That way I'll get 2 moles of electrons to cancel. So I'll end up with tin solid and 2 moles of silver 1 produces a mole of tin 2 and 2 moles of silver solid. And my E0 cell would be a positive 0.94 volts. So let's plug it into our expression. My E cell is going to be E0 cell, positive 0.94 volts minus 0.0592, N is 2, log of Q. Now Q is products over reactants. So I'll have the concentration of tin all over the concentration of silver ion, but it has to be squared. So what is my tin concentration? 0.01 molar. Let's go ahead and solve for it. So remember how we did it? Let's get a number equals a log. Oh, the E cell, we need a number for that too. 1 volt. Okay, let's see if we can clean this up now. Remember the game plan, I want a number equals the log, so I can raise both sides of the 10 power. That's the game plan. So it looks like this. 1 equals 0.94 minus 0.0592 all over 2 log 0.01 over silver ion squared. Just to clean it up. So I'm going to take 1 minus 0.94, it equals, times a negative 2, it equals, divide by 0.0592, it equals, I get about a negative 2.027 is the log of 0.01 over silver ion squared. Now raise both sides to the 10 power, I get about 9.3966 times 10 to the negative 3. I'm just carrying a lot of digits, so I don't have to worry about rounding to the end. Equals 0.01 over silver ion squared. Bring the silver ion to the top, bring the other number to the bottom, take the square root, and we'll get it. So we want 0.01 divided by 9.3966 times 10 to the 3 negative. Take the square root. 1.03. Concentration of silver is about 1.03 molar. So what we worked on today, the main idea, I think, is this expression right here. Right? We determine what the half reactions are, so then we can figure out what E0 cell is and the moles of electrons that transferred to get E0 cell. And then they're going to make a measurement on the voltmeter, and then we just solve for the chemical that we're interested in. So we can determine what the concentration is of any compound in that cell reaction as the reaction progresses.